Try this again. Welcome back, chemistry fans. Today we are going to do the Dalton's Law of Partial Pressure Laboratory. That's a lot of mouthful of words. What we're going to try and do is we're going to have two different reactions, and we're going to combine them together to show that the property is summative. So we're going to have one reaction, and it makes an amount. We're going to have a second amount, and we're going to combine them together, and it should show that we have a total that is twice as big as the original. All right, so let's get into the surface of the chemistry and let's see if we can do this together. Okay, you can see that now I've got a busy surface here that we've got two chemicals to start with I want to highlight. So I've got bleach, top job, and I have hydrogen peroxide as well here. And so when I mix these two chemicals together in a Erlenmeyer flask, it is going to produce an oxygen gas, and water will be the other byproduct of this. And so if I design this well enough, I will be able to capture that gas, and we'll be able to compare it to the second part, which we will discuss in just a second. So process is that we will measure out our quantities, we will pour them together and collect a gas. The second part of our reaction is going to be over here where I have two other chemicals. I've got baking soda and I have vinegar. This is your volcano experiment. Same thing is we're going to mix these together into an Erlenmeyer flask, and this time what it will produce is salt and carbon dioxide gas. And if I design this well enough, we'll be able to compare these two balloon sizes, and then we're going to do it a third time where we add all the chemicals together. So let's get into this and let's watch this reaction occur. So here we go. We are going to first start with our bleach, and we are going to measure out 25 milliliters. If for some reason you get bleach on your fingers, don't wipe it on your clothes. It will bleach your clothes. So we measure out 25 milliliters of the bleach. If you get it on your fingers, please rinse those off immediately. If you get them in your eyes, that's because you weren't wearing goggles, which you should be wearing goggles right now. Second, we are then going to take our hydrogen peroxide, and we are going to measure out equal quantities, 25 milliliters of the hydrogen peroxide. So now I have equal quantities of both. They're both clear liquids. This one's a little bit more yellow than the hydrogen peroxide, so you would be able to distinguish that. Also, the smell on the bleach is a little bit more pungent than it is with the hydrogen peroxide, so don't take big whiffs of them. That's not a good choice. All right, so what I'm going to do to start this is I'm going to take my Erlenmeyer flask and I'm going to pour into it the 25 milliliters of the bleach. So I've got my bleach in there now. And what I'm going to do next is I'm going to take one of my balloons that is labeled with O2, that's the product. I'm going to put my funnel into the mouth of the balloon, and I'm going to pour this hydrogen peroxide into the balloon. And that way, I can control when the experiment is going to take place. So now what I'm going to do is I'm going to put this balloon with the weight of all the liquid below the surface of the mouth of the flask. So now they still haven't interacted, but they are in the same container, essentially. So if I lift up this balloon now, I should see an instant reaction with the oxygen being produced with the bleach and the hydrogen peroxide. And now it's going to be quite violent. It's going to fill up quite rapidly. So you need to make sure that you are holding on to the balloon so it doesn't fly off, because it's going to happen really, really quickly that this reaction occurs. So now you notice I've got one quantity of gas, and once the reaction has occurred, it's pretty much done. So it's not going to try and fly off after it's done. So it has pretty much gotten itself going. It's a little bit precarious there, but it looks like it's going to hold pretty well there before it doesn't burst. So don't shake it up anymore. Otherwise, you might get a little bit more gas than it's able to hold. All right, so we've got one quantity here. Now, we're going to move over here to my second reaction, and I am going to have to weigh out 2 grams twice of my baking soda. So I'm going to do this twice, and I've got it on the scale. And it's hard for you to see, but I will place this down now so that you can see that I'm going to get 2 grams of baking soda placed into my weighing boat here. So I'll just keep going. I'm going to do this twice. So I've got it there. That's 1.4 grams. If I sprinkle a little bit more, 1.8, 2 point. It's close enough. Don't have to get it exact. Pretty close. So I've got one quantity. I'm going to do this now a second time. And because that container doesn't weigh the exact same thing, I'm going to tear that. I'm going to put 2 grams into this one, and you'll understand why we've got to do this twice in just a second. We're going to try and do the summative part of the property. So I've got 1.92, 2.05. So that is close enough for us. All right, so now I have 2 containers of baking soda. I'm going to put them into these balloons. So again, I'm going to be using my funnel to try and prevent the reaction from occurring before I want it to. So I'm going to take my powder, and it's going to be a little awkward to get a solid into this balloon, but that's what we're going to try and do. So I'm going to put that into one of my balloons, and if it doesn't fit exactly what you can see, it's starting to bottleneck down here. We are going to have to get something sharp to try and force it down into the balloon. So I am continuing to push this down in here so that it can make its way into the balloon. And you'll notice there's no more left over. So I got all 2 grams of my baking soda into one of my balloons. Good. I'm going to do the same with my other balloon. And this one again is labeled carbon dioxide. So I'm going to put all of my 2 grams into this one. And again, it seems to get bottlenecked. So I'm going to have to force that down in to the surface of the balloon, trying not to tear the balloon, as I don't want to push too hard to force it down too far into the balloon. Otherwise, it will probably put a hole in my balloon. So there we go. We've got it going in all inside the balloon. So I've got 2 balloons that have 2 grams of baking soda in both. All right, now we're going to go to the vinegar. So now we're going to pour 25 milliliters of vinegar into 2 of my graduated cylinders. Now, we're not going to do these simultaneously. We're going to do these differently on the second one. But the first one, I want to try and create the exact same phenomenon that I did for the first part of the experiment. So I've got this balloon. It has baking soda in here. So I'm going to take my vinegar and I'm going to pour it into my graduated cylinder, into my Erlenmeyer flask. Now I'm going to put the balloon onto the surface of the Erlenmeyer flask, not allowing all of the solids to mix in so they're in the same container. I'm going to now come in here and we're going to lift up the solids and allow them to mix. And as they mix, we should, again, if you hold on to the surface, if you hold on to the lip of the balloon, we should see where we are creating some carbon dioxide gas. Now, if we were to compare, let's take a step back, the carbon dioxide and the oxygen. Well, they look just about the same. They produce just about the exact same amounts. So how are we going to add these 2 together to prove that they're summative? Well, what we're going to do is the next step in the procedure. So we are going to take the oxygen and we are going to add it to a second balloon. So hang tight. Here we go. All right. So I'm going to put this off to the side. And we're going to do a second one of the oxygen so we can have some comparison over here. So we're going to do the exact same procedure that we did before. We're going to take 25 milliliters of the bleach. And I spilled a little bit, and we will clean that up in just a second. And we will pour that into the Erlenmeyer flask like we did previously. And we will pour 25 milliliters of the of the hydrogen peroxide. And we're going to put that then into the balloon a second time. Pour that in with the funnel. And this is the oxygen balloon, so I'm pouring this in. So we're collecting the exact same gas. You're asking, why are we doing this twice? You will see in just a second, but we have to do it twice. All right, so now, again, it's in. Hold on to it so it doesn't shoot off. I know that's hard for you to read, that says O2. And basically notice it's about the same size all the times. They're all about the same. So hold on to your balloon so it doesn't shoot off. Okay, now here's where the magic happens. So I'm going to set these to the back here. That's what we're going to compare them to. Now what we've got to do in this other test tube, or in this other Erlenmeyer flask, where we measured this amount in this balloon, I actually don't need this one. I screwed that one up. What we're going to do is we're going to take a plastic bag and we're going to cut it. We don't need the top portion of the bag. We only need the bottom portion of it, and that's where I'm going to put my 2 grams of baking soda. So I'm going to pour that baking soda right in here. And I know I spilt just a little bit on the table. That's okay. We'll just brush that right into my baggie. So I've got now 2 grams of baking soda in this bag. Here's where it gets odd. I'm going to pour my 25 milliliters of vinegar, and now I've got to try and wad up this bag as an entire particle and try and force it down inside here and get it into the liquid without reacting. So we got to hold it against the side and slide it down. And this plastic bag, we got to make sure that it doesn't get exposed to the liquid. So we got to make sure that it doesn't open up and allow all of the chemicals to react. So notice I've got the tube materials in the same container, but they're not reacting. Right? Good, 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 good. No reaction. No gas should be evolving. So now what we're going to do, we're going to take this O2 container. I'm going to twist it so it seals off the gas. I'm sealing off the gas, and I am removing the balloon. I am now going to take that back to this that has the sealed compartment. This is going to take teamwork. I'm not a team, but I'm going to try and do this as a team. So I am going to try and get this balloon onto my vinegar and baking soda without causing the reaction to occur prematurely. So it's going to take some effort on your team's part to make this happen. I am but a mere solitary individual, so this is a little harder for me, but I've got it, except for my balloon just ripped. So this is going to make it even more interesting. So I am now got my oxygen and I have all my chemicals. I'm going to let go of my oxygen, and now I'm going to start shaking up this chemical and getting all of my vinegar and baking soda added together so that the reaction can start to occur, and we should start to see some fizzing. So now I've got things that are coming and mixing together, the vinegar and the baking soda. So let me pull back my camera just a little bit, and what you can start to notice is, oh wait, the sum of the oxygen and the carbon dioxide is the same as the O2 is over here, but this also has carbon dioxide in it. So it's summative. This is Dalton's law of partial pressure. It's individual pressure equals total pressure. Both of the chemicals are in the same container. There is carbon dioxide being produced. We already have the oxygen in here. So summative properties. And now once I let go, it's all going to go to poo. There it goes. But that was the idea. So that's everything that I wish to share with you today. This is the law of Dalton's partial pressures. Thank you for watching. Have a good day. Bye-bye.